In this video, I'd like to address a common confusion among many students, which is how to integrate these types of reciprocal functions. They look quite similar, but the results are quite different. To integrate the following four functions, we're going to be making use of two basic integrals. The first one is going to give us a result that is a logarithmic function. Here, what we need to look for is that the numerator is the derivative of the denominator. The second one, we're going to be using the reverse chain rule. Here, we're looking for a function f of x that is raised to the power of n. N can be positive, negative, integers, or fractional, as long as n is not equal to -1. The function f of x to the n is then multiplied to f dash x. Let's start with our first example. Our first example, we're going to be integrating the function 2 over x minus 3. The first step I'm going to do is to take out the 2. So we've got 2 times the integral of 1 on x minus 3 dx. Now, if we let the denominator x minus 3 be our f of x, then we see that f dash x is simply equal to 1. So we've got this scenario where we've got f dash x on f of x. So therefore, the integral is equal to 2 times ln absolute x minus 3 plus c. Our second example looks very similar to the first, except this time we've got the power of 4 on the denominator. The numerator clearly is the derivative of the denominator. What I'm going to do first is to again take out the 2 and using the negative index law, rewrite this as x minus 3 to the -4 dx. Now, if we let f of x to be equal to x minus 3, f dash x is equal to 1. The power of -4 is n, so n is equal to -4. This time we can use the reverse chain rule, and the integral for this would be 2 times 1 on n plus 1, which is -4 plus 1, times f of x to the n plus 1, which is x minus 3 to the power of -4 plus 1 plus c. And if we simplify this, we're going to get minus 2/3 times x minus 3 to the power of -3 plus c. And simplifying it further, we'll get minus 2 all over 3 times x minus 3 cubed plus c. Our third example, we've got 2x on x squared minus 3. This time, if we let f of x to be equal to x squared minus 3, then f dash x is going to be equal to 2x. So you see that we've got the first scenario where we've got f dash x on f of x. So the integral of this is simply equal to ln absolute of x squared minus 3 plus c. Our last example, we've got 2x on x squared minus 3 to the power 4. This looks very similar to our third example, except again, we've got the power 4 on the denominator. What I'm going to do first is I'm going to rewrite this integral as 2x times x squared minus 3 to the power of -4 dx. This is from using the negative index law. Then I'm going to let f of x equal to x squared minus 3. So f dash x is equal to 2x. So you can see that f2x is essentially f dash x. The -4 is the power, so n is equal to -4. So we can use the reverse chain rule to integrate this, and we're going to get 1 on n plus 1, which is 1 on -4 plus 1, times f of x to the n plus 1, which is x squared minus 3 to the power of -4 plus 1 plus c. And if we simplify this, we'll get minus 1/3 times x squared minus 3 to the -3 plus c. And simplifying further, we'll get minus 1 on 3 times x squared minus 3 cubed plus c. Thanks everyone for watching the video. I hope you guys found that useful and helped to clarify some confusion. If you're looking for more videos on this topic or other topics, please have a look at our channel. We do release videos weekly, so if you haven't already, don't forget to subscribe. We hope to see you all in the next one. Bye for now.